For centuries, Angkor was seen as a city of temples. Stone towers rose from the jungle, carved with gods and symbols of power. What remained visible were monuments of belief. What shaped the city, however, was something far less obvious. Stone was never Angkor's greatest achievement. Water was. Beneath the ruins lies one of the largest engineered water systems of the ancient world. A system designed not for beauty, but for survival. Angkor stood in a region of extreme seasons. Heavy monsoon rains were followed by long, punishing droughts. Water arrived all at once, then vanished for months. A large city could not survive without control. Floods could destroy fields in weeks. Droughts could starve populations just as quickly. Engineering here was not optional. It was the condition that allowed Angkor to exist at all. The Khmer builders did not try to eliminate water. They chose to control its timing, direction, and force. This single decision defined Angkor's rise. It also defined its limits. Instead of walls and fortresses, Angkor invested in canals and reservoirs. Instead of defensive barriers, it built flow paths. The city itself became an engineered surface. Every slope and channel mattered. At the heart of this system were the Bere. These massive reservoirs stretched for kilometers, holding millions of cubic meters of water. They were not symbolic lakes or ritual spaces. They were functional storage designed for precision. During the monsoon, excess rain was captured and slowed. During the dry season, that water was released gradually into canals and fields. Timing mattered as much as volume. Too fast meant destruction. The canals were not random ditches. They followed carefully calculated gradients that allowed gravity to do the work. Water moved slowly, deliberately, and predictably. Speed was avoided because speed erodes control. Spillways regulated pressure during extreme rains. Excess water was redirected before it could damage embankments. The system absorbed extremes instead of resisting them. Flexibility was built into the design. Angkor's roads, temples, and neighborhoods followed this hydraulic logic. The city grew along water pathways, not against them. Urban planning and water management were inseparable. One could not exist without the other. From above, Angkor does not resemble a traditional city. It appears as a grid of lines, rectangles, and channels etched into the earth. These were not streets alone. They were controls. For centuries, this system worked. Rice harvests stabilized. Population expanded. Angkor became one of the largest pre-industrial cities on Earth. Predictability created prosperity. The success of Angkor was not based solely on power or religion. It was based on reliability. Water arrived when it was needed. Fields survived when surrounding regions failed. Maintenance was constant. Canals required clearing. Embankments demanded reinforcement. Engineering here was not a finished act. It was a continuous responsibility. This was not a passive city. Its survival depended on coordination, labor, and attention. Each season tested the system again. Each year demanded adjustment. Over time, the system expanded. New canals were added. More reservoirs were connected. Control became broader and efficiency increased. But complexity carries a cost. Each new connection reduced flexibility. Small failures now affected larger areas. The system became harder to adapt. Climate patterns began to shift. Archaeological records show prolonged droughts followed by unusually intense monsoon floods. Extremes became sharper and less predictable. The margins for error disappeared. During droughts, reservoirs dropped dangerously low. During floods, canals eroded faster than they could be repaired. Stress accumulated quietly, season after season. Failure did not arrive suddenly. Sediment clogged channels. Embankments weakened. Water began flowing where it was never intended to go. Control slipped away incrementally. The same canals that once protected Angkor now accelerated damage. Water moved too fast, cutting into infrastructure. Efficiency turned into vulnerability. The system began working against itself. Maintenance could no longer keep pace. Labor shortages, political strain, and environmental pressure compounded the problem. Repairs lagged behind damage. Control was lost gradually. Angkor did not collapse in fire or conquest. It unraveled slowly, through repeated seasons of failure. Each year weakened confidence. Each harvest became less certain. Fields flooded unpredictably. Crops failed more often. Population declined as reliability disappeared. Stability, once Angkor's strength, became its weakness. Temples were not abandoned first. Water systems were. When water control failed, the city could no longer function as a whole. The machines stopped. Vegetation reclaimed the canals. Trees grew where water once flowed. Stone structures remained, but the logic that sustained them was gone. The city faded into the landscape. For centuries, this vast hydraulic network remained hidden. Dense jungle concealed reservoirs and channels. Angkor appeared smaller than it truly was. Its greatest achievement lay unseen. Modern technology changed that perception. Satellite imagery and LiDAR scanning stripped away vegetation digitally. The city reappeared as an engineered system. Its true scale became visible. Archaeologists could finally see Angkor as its builders intended, not as isolated monuments, but as an integrated landscape. Every feature had purpose. This discovery reshaped how ancient cities are understood. Angkor was not merely religious or political. It was infrastructural at its core. The builders understood water as a force that could be delayed, redirected, and distributed. They engineered time into the land itself. Flow was measured in seasons, not seconds. Water arriving too early was stored. Water arriving too late was preserved. Timing became a form of engineering. Control meant patience. This required deep environmental knowledge. Builders observed rainfall, soil behavior, and seasonal cycles over generations. Knowledge accumulated slowly, then hardened into design. Engineering principles were not written in manuals. They were embedded in terrain. The landscape itself became a living blueprint. Angkor demonstrates that ancient engineering could operate at enormous scale. Without metal pipes or digital models, builders reshaped entire watersheds. Coordination replaced machinery, but Angkor also reveals engineering limits. Systems optimized for one climate struggle when conditions change. Adaptation must keep pace with reality. Success created dependence. When the system faltered, there was no alternative infrastructure. Resilience had narrowed over time. Angkor did not vanish because its builders lacked intelligence. They were highly skilled. They simply faced conditions their system was never designed to handle. The city reminds us that engineering success is temporary if it cannot evolve. Control without adaptability becomes a risk. Complexity demands constant renewal. Modern cities now face similar challenges. Flood control, water storage, and climate instability define urban survival once again. The parallels are unmistakable. Angkor's story feels ancient yet familiar. It mirrors the balance between ambition and environment that still shapes our world. Technology alone is never enough. The ruins we see today are not the remains of ignorance. They are the remains of mastery pushed to its limits. Success tested by change. Angkor was not simply built in a jungle. It was built on water, and water decided its fate. When control over water was lost, the city followed. Infrastructure failed first, and society followed after. The order matters. Angkor reminds us that the greatest cities are sustained by systems, not monuments. Stone endures, but systems decide survival. Engineering is responsibility, not just achievement. Engineering does not end when construction stops. It ends when adaptation fails. That lesson lies beneath Angkor's temples. And it is a lesson the modern world is still learning.